What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you the difference between ephemeral and non-ephemeral ports. So let's get into it. In the realm of computer networking, understanding ports and their functionalities is crucial for IT professionals, network administrators, and cybersecurity experts. Ports, these are endpoints in the transport layer of the Internet Protocol suite and are essential for directing data packets to the correct applications or services on a host. Among these various types of ports, ephemeral ports and non-ephemeral ports, they stand out due to their specific roles and characteristics. And in this video, we're going to go over the definitions, uses, and distinctions between ephemeral ports and non-ephemeral ports, providing a detailed understanding of their significance in networking. All right, so before diving into the specifics of ephemeral and non-ephemeral ports, it is essential to grasp the basic concept of ports. So in networking, a port, this is a virtual point where network connections start and end. In ports, they allow multiple network services to run on a single host with a single IP address by differentiating traffic based on port numbers. And the Internet Assigned Numbers Authority, they oversee the assignment of port numbers, ensuring consistency and standardization across the Internet. Also, ports are categorized into three main ranges. So you have what are known as well-known ports, and this goes from port 0 all the way to 1023. And these ports are reserved for system or root processes and are well-known and widely used for standard services like HTTP, HTTPS, FTP, and DNS. Then we have what are called registered ports, and they go from 1024 to 49151. And these ports are assigned to user processes or applications that require network communication, but are not as widely standardized in well-known ports. And applications, they can register these ports with the IANA to avoid conflicts. And then we have what are called dynamic or private ports, and they go from 49152 to 65535. And these are also known as ephemeral ports. And these are short-lived ports used by client-side communications, and they are typically assigned dynamically when a connection is initiated and are released once the communication ends. All right, so moving on, let's talk about exactly what an ephemeral port is. So ephemeral ports are temporary, short-lived ports assigned by the operating system for the duration of a communication session. They are typically used for client-side applications to establish connections with server-side applications. And the range for ephemeral ports is usually from 49152 to 65535, although this can vary depending on the operating system and its configuration. And here are the key characteristics of ephemeral ports. So they are dynamically assigned. So ephemeral ports, they are allocated dynamically by the operating system when an application requests a network connection. And once the session ends, the port is freed and can be reassigned for future connections. Also, the lifespan of an ephemeral port is limited to the duration of the connection. And after the connection is terminated, the port becomes available for reuse. Ephemeral ports, they are primarily used on the client side of a network connection. So for example, when a web browser or a client connects to a web server, it uses an ephemeral port to communicate. And also the range of ephemeral ports, like I stated earlier, is typically high, anywhere from 49152 to 65535, which reduces the likelihood of conflicts and ensuring ample availability for numerous concurrent connections. And here's an example of ephemeral port usage. So consider a user accessing a website, and the process involves the following steps. So the user's web browser or the client initiates a connection to the web server's IP address and well-known port. The operating system assigns an ephemeral number to the browser for this specific session. The browser communicates with the web server using the assigned ephemeral port. And once the user finishes browsing and closes the connection, the ephemeral port is released and can be used for future connections. All right, so moving on, let's talk about what a non-ephemeral port is. So non-ephemeral ports, they are also known as static or fixed ports, and they are used for long-lasting or persistent services and are typically associated with well-known or registered port numbers. And these ports are predefined and remain constant, allowing clients to know which port to use when connecting to a specific service. And here are the key characteristics of non-ephemeral ports. So once again, they are predefined and static. So non-ephemeral ports have predefined static port numbers that do not change. These ports are often reserved for specific services and protocols. Also, unlike ephemeral ports, Non-ephemeral ports are associated with services that run continuously or for extended periods, and they are not dynamically assigned and remain in use as long as the service is active. Also, non-ephemeral ports are typically used on the server side of the network connection, and the server listens on these ports for incoming client connections. And then another characteristic is that of standardized port numbers. So well-known ports such as 0 through 1023 and registered ports, which is 1024 to 49151, they fall into the category of non-ephemeral ports, and these ports are standardized and documented by the IANA. Also, here's an example of a non-ephemeral port. So consider a web server hosting a website. The process involves the following steps. So the web server runs an HTTP service listening on the well-known port 80. A client, such as a web browser, initiates a connection to the server's IP address and port 80. The server accepts the connection and communicates with the client using port 80. The server then continues to listen on port 80 for additional incoming connections from other clients. All right, so understanding the differences between ephemeral and non-ephemeral ports is crucial for effective network management and security. And here are the primary distinctions. So we have assignment and lifespan. So ephemeral ports, once again, these are dynamically assigned and short-lived, and they are used for the duration of a single communication session, and then they are released. And then we have non-ephemeral ports. They are predefined and long-lived, and they remain constant and are associated with persistent services. Then we have usage. So ephemeral ports, they are primarily used on the client side for initiating connections, and non-ephemeral ports, they are typically used on the server side for listening to incoming connections. Then we have the port number range. So ephemeral ports, they have high number ranges, although the ranges can vary by operating system. And non-ephemeral ports, they typically have lower number ranges, including well-known and registered ports. Another difference is that of function. So ephemeral ports, they facilitate temporary connections and client-side communications, while non-ephemeral ports, they support persistent services and server-side applications. And examples of the two are as follows. So ephemeral ports, they can be web browsers, email clients, and other client applications that use ephemeral ports to communicate with servers. And then non-ephemeral ports, this could be servers hosting web services such as HTTP or email servers such as SMTP and other well-known services. All right, next let's go over some security considerations. So both ephemeral and non-ephemeral ports, they play a critical role in network security. So understanding their usage and potential vulnerabilities, this is essential for maintaining a secure network environment. So the security considerations for ephemeral ports are as follows. So they are dynamic in nature. So the dynamic assignment of ephemeral ports can make it challenging to predict and monitor all active connections. So implementing robust network monitoring tools, this can help track ephemeral port usage and detect anomalies. Then you have to deal with firewalls and network address translation. So configuring firewalls and NAT devices to handle ephemeral ports appropriately, this is crucial. And firewalls, they should allow ephemeral port traffic while ensuring unauthorized access is blocked. And then we have port exhaustion. So in scenarios with a high volume of client connections, there is a risk of ephemeral port exhaustion. So properly configuring the ephemeral port range and implementing connection limits, this can mitigate this risk. And here are the security considerations for non-ephemeral ports. So the first one is that of known targets. So non-ephemeral ports, they are well known and documented, making them common targets for attackers. So ensuring services running on these ports are securely configured and regularly updated, this is essential. Then there's access control. So you want to implement strict access control measures for non-ephemeral ports to prevent unauthorized access. And firewalls, intrusion detection systems, and access control lists, they should be configured to protect these ports. And then there's port scanning. So attackers, they can often use port scanning techniques to identify non-ephemeral ports. So employing port scanning detection tools and limiting the exposure of non-ephemeral ports, this can enhance security. Understanding the practical applications and use cases of ephemeral and non-ephemeral ports, this can provide insights into their significance in real-world scenarios. So here are some practical applications of ephemeral ports. So we have that of web browsing. So when a user accesses a website, the web browser uses an ephemeral port to establish a connection with the web server's non-ephemeral port. We have email clients. So email clients, they use ephemeral ports to connect to mail servers for sending and receiving emails. And the mail server, it listens on non-ephemeral ports such as port 25 for SMTP or port 143 for IMAP. And then there's file transfers. So FTP clients, they use ephemeral ports to establish connections with FTP servers, which listen on non-ephemeral ports such as port 21 for FTP control commands. And then here are some practical applications for non-ephemeral ports. So we have web servers. So web servers, they run HTTP or HTTPS services on non-ephemeral ports, allowing clients to connect and access web content. You have database servers. So database servers, they listen on specific non-ephemeral ports to accept client connections for database operations. And then there's remote access. So remote access services such as SSH and RDP, they utilize non-ephemeral ports to provide secure remote access to servers and workstations. All right, next let's talk about port management and best practices. So proper management of both ephemeral and non-ephemeral ports. This is essential for maintaining an efficient and secure network. So here are some of the best practices for managing these ports. So you want to configure ephemeral port ranges. So you want to customize the range of ephemeral ports based on the network's needs and operating system capabilities. And you want to ensure the range is sufficient to handle the expected number of concurrent connections. You want to monitor the port usage. So you want to implement network monitoring tools to track the assignment and usage of ephemeral ports. And this helps in identifying potential issues such as port exhaustion or abnormal traffic patterns. You also want to secure client applications. So ensure client applications that use ephemeral ports are updated and secure, because vulnerabilities in client applications, they can be exploited to gain unauthorized access or disrupt services. And then you want to do some network address translation and firewall configuration. So you want to properly configure NAT devices and firewalls to handle ephemeral port traffic. And then you want to ensure that the necessary ports are open for legitimate traffic while blocking unauthorized access. And here's how you go about managing non-ephemeral ports. So you want to minimize open ports. So only open non-ephemeral ports that are necessary for the required services. Closing unused ports, this reduces the attack surface and enhances security. You want to use strong authentication and encryption. So implement strong authentication mechanisms and encryption for services running on non-ephemeral ports. This helps protect data in transit and prevents unauthorized access. You want to do some regular updates and patching. So keep software and services running on non-ephemeral ports up to date with the latest security patches. This mitigates vulnerabilities that could be exploited by attackers. You want to implement access controls. So use firewalls, intrusion detection prevention systems, and access control lists to restrict access to non-ephemeral ports and only allow trusted sources to connect to these ports. Then you want to do some port scanning. So you want to employ port scanning detection tools and techniques to identify and respond to port scanning activities. This helps in detecting potential reconnaissance efforts by attackers. All right, so moving on. With the increased adoption of cloud computing and virtualization technologies, the management of ephemeral and non-ephemeral ports has become even more critical. Cloud environments, they often involve dynamic scaling and multiple instances, which necessitate effective port management strategies. So when it comes to ephemeral ports in cloud environments, there's this concept called auto scaling. So cloud environments, they can automatically scale resources up or down based on demand. So managing ephemeral ports efficiently, this ensures that new instances can communicate effectively without port conflicts. Then we have load balancing. So load balancers, they distribute incoming traffic across multiple instances, and proper configuration of ephemeral ports. This ensures smooth communication between clients and instances behind the load balancer. Then we have security groups and network ACLs. So use cloud provider specific security groups and network ACLs to manage access to ephemeral ports, because this provides an additional layer of security by controlling traffic at the network level. When it comes to non-ephemeral ports in the cloud environment, you have service discovery. So in dynamic cloud environments, service discovery mechanisms, this helps clients locate services running on non-ephemeral ports. And implementing robust service discovery solutions, this ensures seamless connectivity. You have your firewall rules. So you want to configure firewall rules to allow traffic to non-ephemeral ports from trusted sources. And this is crucial for protecting services running on these ports from unauthorized access. And then there's monitoring and logging. So you want to use cloud native monitoring and logging tools to track the usage and performance of non-ephemeral ports, and this helps in identifying potential issues and ensuring service availability. And then we have ephemeral and non-ephemeral ports and virtualized environments. So we have virtual machines and containers. So both VMs and containers, they use ephemeral and non-ephemeral ports for communication. So properly configuring network settings, this ensures efficient port management and communication between virtualized instances. You have network overlays. So virtualized environments, they often use network overlays to connect instances across different physical hosts. So managing ports within these overlays is crucial for maintaining network performance and security. And then we have isolation and segmentation. So you want to use network isolation and segmentation techniques to manage access to ephemeral and non-ephemeral ports within virtualized environments, because this helps in preventing lateral movement by attackers and containing potential security breaches. All right, so to wrap all this information up, understanding the differences between ephemeral and non-ephemeral ports is fundamental for anyone involved in networking, IT, or cybersecurity. Ephemeral ports, they facilitate temporary client-side connections, while non-ephemeral ports support persistent server-side services. And both types of ports play crucial roles in network communication and security. By implementing best practices for managing ephemeral and non-ephemeral ports, IT professionals, they can ensure efficient network operations, enhance security, and mitigate potential risks. Whether working in traditional cloud or virtualized environments, effective port management, this is key to maintaining a robust and secure network infrastructure. And in the ever-evolving landscape of networking, staying informed about port usage, security considerations, and emerging technologies, this will empower professionals to adapt and thrive. So as networks grow in complexity, the knowledge and skills to manage ephemeral and non-ephemeral ports effectively will remain invaluable.